Now the question then comes up is how do we measure our progress? And this is kind of one of the areas in terms of research that's really kind of interesting. Just like you do return on investment for normal financial investments, we should be looking at things like energy payback time, or water, or materials, or consumable payback time, or other returns on the investment, decrease in impact per unit of GDP. We should be measuring societal impact. For example, companies like Ray Anderson with Interface Carpets, they do things like the diversion of waste to landfills as a measure of societal improvement. Reduce your carbon footprint. Measure it, reduce it, track it. Other efficiencies that are more related to thermodynamic principles, for example, use of available energy, or so-called exergy. And hybrid measures, for example, reduced air pollution, the diversion from landfill, reduced healthcare costs because of improved air quality and reduced asthma, things like that. Very important. There's a term called energy payback that basically indicates how long, if you make a change in a process, it takes you to accumulate the savings from that process to pay back the embedded energy, resources, materials that were used to make that change in the first place. You want to make sure that's a positive number and it's not an infinite number. It has to be a reasonable return on investment. Otherwise, you're not actually making a holistic improvement. Finally, this has to be done at every level, from design to the device, to the production system, to the company, to the sector, through the entire society. And I think that's an important part of this discussion. The reason that these guys made these tremendous improvements in paradigm changes in manufacturing in the past was essentially that they looked at an integrated approach. It may have been within a certain part of their production cycle, but it was integrated, and it changed the way they did business. And that's what we have to do at this point as well. Let me give you a couple of examples here in terms of things that can be done. So I'm a machine tool guy, a manufacturing person, so this is a machine tool in the center. If you think about looking at this machine as part of a production system, manufacturing components, say for an automobile or a solar cell or a laptop or whatever, there's a number of ways that we can actually take a look at how we can improve the system, how we can make changes. There's just how you build the machine, embedded energy, resources, how you deliver it to your customer. The supply chain impacts on that. How you run the machine, is it efficiently operational in terms of are you making value added of your time? How you process at the large scale or the small scale what's done on that machine stepwise using the tooling, efficient operation, and how you organize that machine in a complete system and it runs in your factory. Are you making the best use of the efficiencies and making sure that you have smooth operation from one step to the next from the point of view of impacts that we've been talking about previously? If we kind of take a look at manufacturing systems akin to the one that I talked about previously, machine tool or conventional manufacturing, what kind of strategies can we draw from this discussion that get us started, get us moving on this direction towards sustainability, to allow us to use these metrics that we talked about? First of all, we have to have metrics. We have to have an understanding of where we are. Right? If you don't know where you are, you can't tell whether you're going forward, backward, sinking, floating, whatever. So we need to have business intelligence analytics. Analytics in terms of design characteristics, help engineers to make products, business intelligence to tell you where you are in the world of sustainable development and progress, to tell you where you are and how you're moving, especially compared to your competitors if you can do that. All aspects of manufacturing flow and the design and the supply chain have to be considered as part of this. Don't leave anything out. To the extent you can add elements that are service-oriented to your business, it's very good, right? All kinds of businesses, service-oriented businesses, whether you lease or lean or loan materials and you take things back into consideration after they've been finished in the life of the consumer or the product, service-oriented business have some advantages. Minimize the use of material energy. Okay, this is something that many people do anyways, but this is an additional incentive to do that. Use input materials that are less toxic, less hazardous, have less embedded energy whenever possible. Substitute when reasonable. Reduce the outputs of your process. Okay, try to find ways to minimize packaging, waste, scrappage, increase yield, which is done anyways, but in this case you can have a green aspect to it that's very useful. To the extent you can convert outputs to inputs, get as close to the left-hand side of the Comet cycle as possible, That's really helpful. We could go on in some detail, but this gives us kind of a frame of reference for doing it, and how we flesh that out, perhaps we'll discuss in future discussions or webinars. Okay, we've been going for quite a while here, a lot of material. Let's kind of put a point on it and see at least what I think we should be learning from this. First of all, we should see this as an opportunity. Just as the other paradigm shifts that occurred were seen as opportunities for improvement and extracting value from systems that made us more competitive, we have to think of this as an opportunity. We have to think about it in a global sense, the complete supply chain, but we have to make sure at a detailed level we know what we're doing, what we're operating, what changes we're making. Think globally, act locally. Very Berkeley phrase. Wasting any resource is costly, okay, whether it's time, whether it's energy, whether it's any kind of materials. Think of it extended beyond just the simple standard return on investment, but in terms of its impact and what was used to get it to your facility and minimize the use of these materials and waste. Make sure we can have a business case that includes life cycle costs. Make sure the supply chain is completely included, both upstream and downstream. And finally, from the point of view of both business aspect and engineering and manufacturing aspect, take advantage of analytical tools to enable these decisions and trade-offs so you know what your return is, you know what you're doing, and you're not just kind of taking the plunge and hoping it'll work out all right. We could go on at some length, but essentially I think we'll stop at that point because I know we've got an opportunity for some questions and answers. So I want to thank you for your attention and look forward to getting some feedback and continuing the discussion either here or offline after we finish. So I'm going to turn it back to Frankie, and he's going to continue.
Thank you, David. We do have time for question and answers. Members of the audience, you should type your questions into the webinar panel, and we'll see those coming up. I see a couple coming in right away. Also, Corinne Reich-Weiser is here, and she's also an expert in green manufacturing, and she's going to help with some of the Q&A.
Thank you, Frankie.
So, David, I've got a question here from Dylan. It says, what would you suspect the impact of technologies that reduce the necessity for hard tooling, and uses the example of laser projectors, will have on the future of sustainability?
That's a great question. The extent to which you can either extend the use of any kind of tooling, let's talk about tooling specifically, extend the use over a wider range of product or processes of any particular piece of tooling is very important. What you have to do, of course, is to make sure that when you do your trade-off analysis between, let's say, a suite of hard tooling concepts and the use of a laser, to use this specific example, a laser process, that you include the impacts and embedded characteristics of that process. So when you do your calculation, you can fairly make a comparison and understand where the break-even point is. Because I would imagine for highly flexible processes, these kind of flexible tooling will show to be extremely valuable. For less small scale, it is larger scale, it may be a little harder to make, but you want to be able to do that trade-off analysis. So I think kind of flexible tooling, things that extend the range over which a piece of tooling or a piece of machinery can be used without substantial changes as part of its normal mode of operation, is kind of one of these technology wedges that I was talking about that should have great value.